about polynomials, and last week we were working where I would give you one zero and we would find the others, which we had been doing before. We know once you have the first zero, you just divide, but we were focusing on the complex numbers. If you have a complex zero, we know the conjugate also works. We want to today focus on how to use this stuff to draw a graph of a polynomial. So, first question, if I give you a polynomial and it's factored, can you tell me the zeros from that? How do you find zeros? You basically set each parenthesis equal to 0 and solve. So that 3x out in front, it's not a parenthesis, but it still has an x in it. What would make 3x equal 0? 0. What would make 4x minus 5 equal 0? Okay. Now that one was cubed. So what does that mean?
Oh, it's a cube. Like what?
Yeah. It had a third power.
Multiplicity 3.
So the multiplicity is 3. In other words, that's kind of like saying 5/4 would work as a 0 3 different times. Because we know if something's to the third power, you could write that parenthesis 3 times. Alright. If we set x squared plus 3 equal to 0. But it had a fifth power on it, so each one has a multiplicity of 5. And you can write that as a plus and minus. You can also separate it. You can say I radical 3 multiplicity 5 and negative I radical 3 multiplicity 5. Or you can say plus and minus I radical 3 multiplicity 5. It does not matter if you put them together or separate it. Alright. So you know how to find zeros and multiplicities. So now we're going to try to connect all the pieces that we've talked about as we went through this. We've talked about in behavior. We've talked about zeros. When you find a zero, what does that mean on your graph? It's where it hits the x-axis. And way back in a couple sections ago, we talked about how multiplicities impact the graph. What happened if you had an even multiplicity? It would bounce, but an odd multiplicity would go through. So now we're going to take all that stuff together. We know how to find the zeros. We know how to look at it and tell the in behavior. We know if it's going to bounce or go through the zeros, so we can put all that together to draw a graph. One thing we need to stress before we do that, the degree tells you how many zeros you have. Now this says if it's degree n, it has at most n real zeros because they might be imaginary. So if it's a fifth power, you can hit the x-axis at most 5 times. It doesn't guarantee you will hit 5 times because we could have some imaginary zeros in there and we don't graph those. But the degree is the number of zeros. And we know with multiplicity, we just said, even multiplicity will bounce. Odd multiplicity will go through. That's not if the zero is even or odd, that's the multiplicity. So these are kind of the steps that we will go through when we graph our polynomials. First step is the end behavior. Okay, if you're writing this down, I would write the bold points. The rest of it, if you know what it means, you don't necessarily have to write that. So step 2 is to find the zeros. So we have to factor it and find the zeros. Those are the x-intercepts. Step 3, we have to look at the multiplicity, decide if the graph will go through or bounce. Step 4, we find the y-intercept. And then step 5, we will draw the graph. So we're just going to practice this the rest of the class. Alright, so if I want to sketch this, I need the end behavior. To get end behavior, I need degree. So let's go ahead and just write down our degree. Degree is like, if I multiply this all out, what would my highest power of x be? X to the third. So my degree is 3. So that means we'll have how many zeros? At most 3 real ones, yeah. We'll have 3 total. They could be real or imaginary, but that gives us at most 3 x-intercepts. So the end behavior. Okay, if it's an odd degree, we know it looks like a chair. Negative coefficients flip it. So there is not a negative coefficient, so it's like our standard x cubed. So our end behavior is down up. Zeros. So since it's factored, we can just set each parenthesis equal to 0. So what makes 2x minus 1 equal 0? What makes x plus 1? And x plus 3? 3. So my degree is 3, and we have 3 zeros here. All of those are real numbers, so we can graph all of those. And then the next step was, does it go through or bounce? All of these have what multiplicity? 1. 1 is an odd number, so what will the graph do at each of these? Go through all of them. Okay, y-intercept. How do we find a y-intercept? Okay, where you hit the y-axis is when x is 0. So if I plug in a 0 for each of my x's, 2 times 0 minus 1 is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. So my y-intercept is negative 3. And now we can draw the graph. On a test or quiz, you would not necessarily have to just know all the steps. This would be like an A, B, C, D, E question. So I'd say part A, tell me the degree. Part B, tell me the end behavior. Part C, zeros. So I will step you through all the things I want. All right, so we hit the x-axis at negative 3, negative 1, and positive 1. We hit the y-axis at negative 3. My end behavior is down up, so this end should start down here and it should end going up here. Remember, a polynomial we said is a nice smooth curve. So it's not a zigzag, no corners, no breaks in our graph. You're just doing a curve. It has to pass the vertical line test, so don't just draw a straight line up and a straight line down. It is increasing or decreasing. So we hit here. Now, I don't really know how high this goes, so this graph is not perfect, but we have to go through those zeros. Come back, we cross the y-axis here, go through the 0, and it just keeps going up. So is this graph perfect? Absolutely not. Is it close? Yes. We have the correct points on the x and y axes, we have the correct ends. What I don't know is like the height, how steep or how high those curves go. We could get a better idea just by plugging in some more numbers, but this is all that I have to have for you. Is there a way you can kind of double check yourself? Yeah, look at a graph on the graphing calculator and just kind of double check. Do we have the right shape? Appear the same x-intercepts, all those kinds of things. All right. Any questions on this one? Let's do another one. So what's the degree on this one? 4. This one is in fact, or is not in factored form, so my degree is just my highest power, so that's 4. So then what's the end behavior? Okay, now the zeros. Since it's not factored, I don't know my zeros. We know if I give you the first 0, we can get it factored. But I didn't even tell you that. Is there any option for getting this in factored form? Yeah. Remember grouping? Some of our old factoring techniques? So grouping says you put the first 2 together and the second 2 together. What could we take out of the first one? Leaves us with x minus 2. Second one we can take out 8, and that leaves us with x minus 2. So then you take out the x minus 2. We have x cubed plus 8. Is that enough that we could get our zeros? Okay. So what would I have to do? What's my first 0? Okay, to get the other one, if you set x cubed plus 8 equal to 0, what's the cube root of negative 8?
I mean, 2.
Yeah, negative 2. Okay. This seems a little off though, doesn't it? Shouldn't we have 4 zeros? Okay, so what happened is the others are imaginary. If we had used, remember we talked back when we did factoring, there's a formula for sum and difference of cubes. If we had used that to factor the x cubed plus 8, then one parenthesis would have been the x minus, or x plus 2, and the second one would have been a quadratic, and that would have imaginary zeros. So we could get it that way, but is it relevant here? No, because I can't graph the imaginary ones anyway. So it's not a big deal. We know they're there. If we really wanted to find it, we could use that cube formula, but all I need really are the real ones that we can graph. Both of these have a multiplicity of 1, so what does that mean? Yeah. Okay, y-intercept. If you plug in 0 for all of your x's, we could even do that back at the beginning. What do we get? So we hit at positive and negative 2. Y-axis negative 16. I'm going to count by 4s. We started up and we end up. So remember, a nice smooth curve. So something along those lines. when I look at your graphs, I'm going to check, is it curved? Is it a function? So does it pass the vertical line test? Do you have the correct intercepts, bounce through, in behavior, all that? Let's try a couple more. What is our degree? Yeah, we have to think about if we multiply that, we have 2 x's in the first, 3 in the second, so 5 overall. In behavior,
Oh, wait.
yeah, odd degree, so it looks like a cube. It's a positive coefficient, so it's our normal. Zeros. What makes x minus 1 equal 0? And x plus 2? So this one had an even multiplicity, which means the graph will bounce. Okay, 3 is odd, so an odd multiplicity will go y-intercept. If we plug in 0 for all the x's, we have a negative 1 squared, a positive 2 cubed. So that's 1 times 8, which is 0. Your y-intercepts can be big numbers, so please feel free to count by something other than 1. But you do need to label what you're counting by. Don't just put a few tick marks and cross through it there. Make sure you're labeling if it's not ones. So, in behavior, we know it should start down here and end up here. So I'm starting down here, hitting it at negative 2, and at negative 2 my graph should go through. Okay, we hit the y-axis at 8. Come down, we hit at 1, but at 1 our graph bounces. So that means it doesn't go through the axis, it just turns back up there. And then it ends the direction we said. Always, if you get stuck or you're not sure about your graph, you can use your graphing calculator to kind of double check your answers. Any questions there? One. What would our degree be? We have 5, 1, and 4, so altogether is 10. So in behavior, zeros. Well, if this is just an x, what would make it 0? 0. And since it's a fifth power multiplicity of 5. What about x minus 3? It's a 3. It was just to the first power, so you don't have to write multiplicity 1. And then negative 4 multiplicity 4. So at 0, will my graph bounce or go through? You look at the multiplicity. 5 is odd, so odd goes through. 3 is a multiplicity of 1, so it will. Negative 4, the multiplicity is 4, so that will bounce. Y-intercept. If you plug in 0 for all of your x's, what do you get out? Times 0 to the 5th, which is 0. Both ends should be pointing up. We come down, we hit it negative 4, and then what's our graph going to do? Bounce. Negative 4 was a bounce, so it comes back up. But we have to come back and hit this 0, so at some point it's going to come back, hit this. At 0 it goes through. Have to come back and hit the x-axis here. And at 3 it goes through, and that leaves us pointing up, which is what we said. Make sure your x-intercepts, that's where you hit your x-axis, but that's also the only places you can hit your x-axis. So if you are ever graphing and you end up hitting more than the points you plotted, you've made a mistake somewhere. Do you guys have questions on any of these? So I posted a handout on Classroom. I think I'm going to modify. We're not going to do all of them. I'm going to do 1 through 3, 7, and 8.